Lesson 3-9, Step Functions. The big idea is step functions have applications in many situations that involve rounding. We see these in everyday life, it's just that people don't really pay attention to them. We see them in instances of postage, the amount you pay for postage, taxi cab rides, heating, your water bill. All these things are actually, you can graph as a step function, okay? Let's take a look at them. It says in 2007, the U.S. postage rate for first-class flats, certain large envelopes, was 70 cents for the first ounce, plus 17 cents for each additional ounce or part of an ounce. First-class mail rates for flats up to 13 ounces are given in the table below. Notice that the phrase up to and including the given weight means that the weight is rounded up. So for instance, if you have a package that weighs 4.4 ounces, you are actually being charged for the 5-ounce rate, which should make sense. As soon as you go over, as soon as your weight becomes 1.1, you are now paying for a 2-ounce postage stamp. As soon as you get to be 2.4, you're paying for a 3-ounce postage stamp, so on and so forth. As soon as you go past that integer or that whole number, you're paying for the next one over. So if I said I had a package that weighed 3.3 ounces, I'm paying for a 4-ounce package, which would be $1.21. Okay? How do we graph that? Well, we graph it using a function that looks like this. Okay? If you noticed here, at 0 and anything until it gets to 1, the price is going to be 70 cents. If you have a 0.1 weight, it's cost you 70 cents. If you have a 0.2 weight, it costs you 70 cents, so on and so forth. The minute it gets to an ounce, you're still paying 70 cents. But the moment it gets to 1.2, now my function costs me 17 cents plus 70 is 87 cents. And this denotes 87 cents all the way until it gets here to 2 ounces. So you pay 87 cents all the way until you get to 2 ounces. The moment it gets past 2 ounces, you are now at 17 cents plus 87 would be roughly $1.04, right? Which is right here. Pay $1.04 all the way until you get to here, until 3 ounces. The moment it gets past 3 ounces, it jumps up. So on and so forth. This keeps on going forever. It says the mail rate functions is not a linear function, but it is a piecewise linear function. Because its graph looks like a series of steps, we call this a step function. Each step is part of a horizontal line. 2 step functions commonly used are called the floor function and the ceiling function. Okay? Floor function and the ceiling function. This would be a ceiling function due to the fact that the price gets rounded up to the next ounce. Okay? The floor and ceiling functions. The floor symbol. Okay? And the ceiling symbol. Brackets up on top, or just the tabs up on top, are defined as follows. Okay? This is what we call the greatest integer and the least integer functions. Okay? You'll hear me call that too. This is called the greatest integer function. Okay? The floor function is the function f with f of x equaling this right here, the floor function. For all real numbers x, it is also called the greatest integer function or the rounding down function. If the tabs are on the bottom, you're rounding down. Okay? And in some computer languages, it is called the int function, the integer function. Another notation you may see for the floor function is this. Okay, I have never seen that before, but you may possibly get that. The ceiling function is the function f with f of x equaling this right here. The tabs are on top. For all real numbers x, it is also called the rounding up function. Tabs on top, you go to the next integer above it. Okay? You go to the next integer above it. As I had mentioned before, we had a ceiling function, and you go up. Okay? In my last example. Example 1 says, evaluate each of the following. What can help you is making a number line. Okay? Here is 5 and 7/8. Now, what it also helps you to do is put the next integers to the right and to the left of this function. So, the next integer to the right of this function is 6. The integer to the left of this function is 5. Because our answer is going to be an integer. We just got to decide if we got to go to the left or to the right. Well, since the tabs are on the bottom, we want the integer function that is to the left, which is 5. Okay? Same thing here on B. Negative 4.2. The integer to the left would be a negative 5. The integer to its right would be a negative 4. Same process. The tabs are on the bottom, so we want the integer that is to the left. The integer to the left is a negative 5. Okay? For C, pi is 3.14, as we all know. So the integer to the right is 4. The integer to the left is 3. We want the integer that is to above 3.14. The integer above 3.14 is 4. Okay? 13. 13 is already an integer. Okay? So since this is already an integer, we got our answer, which is 13. So if you have an integer in here, it's already the answer. Okay? Moving along. Graphing these functions. Okay? Now, Mr. Johnson has a different way, kind of as the book. The book examined it from a -2 to a -3, which is fine. If you put in a -2 to a -3, say for instance you put in a -2.5, you go down, right? You go down, so it gives you a -3. Okay? Simple enough. If you put in a -1.5, same process. You go down, so it's a -2. Okay? What I like to do is I like to start with 0. If I put 0 in, I get out 0. Okay? If I put 1 in, I get out 1. So I know where that's at. So I got my 2 points here. Now what I need to do is I need to check what it's doing in between. So what I would do for this function is I would put in 0.7. Okay? When I put in 0.7, it goes back to 0. Well, where's my 0.7 at? Well, 0.7 is approximately about right here. So I know all the way until I get to this point, which is 1, I have an open circle here. And I know that's a bad open circle, but that's supposed to be an open circle. And you can see it there. Okay? But I have an open circle all the way until I get to here. And then at 1 it jumps. So then once I know what this looks like, I know the rest of it is going to match. Okay? And you just keep going. So on and so forth. So what I do is I normally start with 0, and then once I start seeing my pattern, I'm able to take off. Okay? Example 3, it says in March of 2008, New York City taxi rates were an initial fee of $2.50 plus 40 cents for each full 1/5 mile travel. Write a formula for T of M, the charge for a trip of M miles. Okay, so we need to put this into miles. Well, they are charging for 1/5 of a mile. So how many 1/5 miles equal a mile? Well, how many 1/5 miles are in 1 mile? Well, there are 5 of them. There's 5 1/5 miles, right? In 1 mile. So 5m is going to be the number that I put in for when I get to my equation for my function. Okay? So, looking at this, as soon as we start driving, they are charging us $2.50. Okay? Plus they are charging 40 cents for 1/5 of a mile. Now what I said is that there's 5 1/5 miles in for each mile. So where I'd normally put miles, okay, and 1/5 of a mile, now I have to put 5 miles because there's 5. We're getting charged 5 times for every mile that we went. I hope that makes sense. And if it doesn't, you can ask me later. But as soon as we're doing this, now this is where you got to ask yourself. As soon as you start driving, are you getting charged for that 1/5 mile? Okay? So, or do you get charged as soon as you get to that 1/5 mile? In a taxi cab, you don't get charged until you get to that 1/5 mile. So what this function is a floor function. Okay? You don't get charged until you drive that 1/5 mile. So say, for instance, if you drove 2 miles and a tenth, okay, a tenth is smaller than a fifth, tenth is less than 1/5. So if you drove 2 1/10 miles, you are only getting charged for 2 miles. Does that make sense? Okay, so we are rounding down in this case. Okay. B says, what is the charge for an 8.75 mile trip in a New York City taxi? Well, let's go ahead and do this. 2.50, and we want to find when T of 8.75, so all we have to do is put 8.75 in for M, plus 0.40, 5 times 8.75. When you take 5 times 8.75 on your calculator, 5 times 8.75 is roughly, or is, 43.75. Now notice, these two things side by side still means multiplication. So I got to find my integer here. My integer here, we're rounding down. So if we're at 43.75, if I go down, I'm going to 43. So I'm only getting charged for 43. Not getting charged for that 0.75. Okay. 43 times 40 cents plus 250 is going to give me $19.70 to go 8.75 miles, which ain't too bad of a price. Maybe in New York. Example 4. Users of prepaid calling cards are billed in 1-minute increments. This means that the customers are billed for a full minute when any part of a minute is used. So it's kind of like the postage deal. As soon as you go to 1.1 minutes, you're getting billed for 2. If the Call Me Often phone card company charges 3 cents per minute with a 1-minute billing increment, what is the charge for a 5-minute, 40-second phone call? Okay, well, here's the deal. It's a ceiling function because it's getting moved up, correct? 5 minutes, 40 seconds is in here, and we take that times 0.03 cents, right? Pen's acting up on me. Or it could just be Mr. Johnson's bad penmanship. Okay? So, my ceiling function takes 5 minutes, 40 seconds takes us to 6 minutes. Okay? It's not taking us down to 5 minutes, it's taking us up to 6 minutes. So 6 minutes times 0.03 is 18 cents. So for that 6-minute phone call, it's going to cost us 18 cents. That's all I have for you today. Please enjoy. We'll see you tomorrow.